Okay, so that was part 1. Part 2 says subtract the base triglycerides by the triglycerides at the follow-up visit. So what happened in the study was that they measured the police officers when they first got hired, and they measured them after. So this poor soul has elevated triglycerides, right? This person, not much difference. This person, things went up by quite a bit. So what you want to do, instead of having to calculate each difference, is I'm going to type equals E2 subtracted by D2. See how E2 is this cell and D2 is this cell? When you tell Excel the cells, not the actual numbers, then hit enter. It's like a program. Now if you click and drag, it moved that program down here. Look, this one is calculating the difference between E3 and D3. So it's calculated that difference for us. And if you click and drag, look, all the differences are being calculated. We don't have to do any number crunching ourselves. So click and drag all the way down. There we go. So now we have a column of information that represents the difference. So look, there's a lot of positive values. That means that triglyceride levels went up. This person went down, this person went up in triglyceride levels over the 5 years, so it looks like, maybe things aren't going so good. Maybe the stress has been linked, I think, to triglyceride elevation over time. Okay, so that's part 2. Part 3, some patients' triglycerides went up and some went down. To get a handle of how they changed overall, calculate the mean and standard deviation of column F for the differences. So this is, I got 2 sheets, sorry. Oh no, this is the wrong sheet. Okay, that's the sheet you're going to be copying from. So column F was when we had the differences. We just did this, so nothing new here. Okay, so what you're going to want to do, and you're not about to see the answer because I haven't done the whole column. You're supposed to calculate the mean and the standard deviation of column F. So that's how I calculate the mean, just like last week. And the standard deviation, type equals stdev.s, because it's sample data. This isn't every police officer, of column F. So we got that part. So that gives you an idea. The mean difference, it looks like it's a positive 10. So like this isn't the correct answer. You're going to need to do it for the whole column F. I only did a part of it, so I didn't give away the answers here. But right now it looks like the mean difference is a positive 10. That means triglyceride levels have gone up. Were there differences in the triglyceride levels between those that smoke and those that do not smoke? So that one is going to involve a sorting question, where you're going to want to do, as soon as my computer cooperates, there we go. Yeah, for this part, you want to sort based on whether they're smokers. So you can just click the top of column B, right click, and then go down to sort sheet like we did last week. And now you've got the non-smokers, 0 is non-smokers here, and then you've got smokers down here. Okay, so you got 2 separate groups. Now it should be easier for you to calculate the mean and standard deviation for non-smokers than the mean and standard deviation for smokers. Was there a difference in the means? And here, I'm going to add more specific language. Calculate the mean and standard deviation. Follow up triglyceride levels. This is column E, sorry, is follow up. Calculate the mean standard deviation follow-up triglyceride levels for non-smokers, and calculate the mean standard deviation for smokers, and see if there's a difference. And then interpret what the standard deviation tells us about those two. Okay, so like one thing I'd be looking out for is, let's say between, like there's a mean for smokers was 80, and then the mean for non-smokers was 70, and the standard deviation here was 15. The standard deviation here was 20. I'd say, look, there's a big spread in both these data sets, and even the difference is 10. But if you were to add a standard deviation down here and subtract a standard deviation here, they'd overlap with each other. So they're within each other's standard deviations away. So that means, yeah, there's a difference, but it's probably not that much of a difference if that was what your data set is. Okay, if that's what your values are. You're going to actually calculate these means and standard deviations, though, for all the ones that have a 0 next to them, then calculate the mean and standard deviation for column E that have 1s next to them, and then compare them. Okay, and so we discussed standard deviation this week. You can talk about what that means for those data sets. Question 5, there were 234 police officers in the study, so what's the probability that a randomly selected police officer was under the age of 35? So we talked about probabilities in the videos this week. Sort this by age, and then you're going to want it starts on 1, so it's nice and easy to count. You can count up how many police officers are under the age of 35, right? By looking at the column numbers. So we're at 86, 87, 88. Count up the number of police officers that are under the age of 35, and then divide by 234. That's our probability that a randomly selected police officer is under the age of 35. And then a little bit tougher now, what's the probability that a randomly selected police officer is under the age of 35 and a smoker? They've got to meet both those criteria. So once you sort by age, then sort by smoker status. And look how Google Sheets does that for us. It keeps all the non-smokers together, and then it puts all the smokers together. So you want to count up all the smokers that are under the age of 35, and then divide by 234. That's how you would calculate that probability. They've got to meet both those criteria. So count up all the people that are under 35 and a smoker, and then divide by 234. And that's the probability that a randomly selected police officer is a young smoker, relatively young. Okay. I hope that helps for this week, but I'm obviously still here for questions, so let me know if you need anything.